Theme 8. Technology Masonry. Lecture Plan, 2 hours. 1. Purpose and types of masonry. 2. Rules for cutting masonry. 3. The performance of a laying from stones of the correct form. 4. System of bandaging of seams and walls. 5. Masonry of irregular stones. 6. Quality control. 7. Basic safety regulations. Significance of stoneworks. Stoneworks, a type of construction work performed in the construction of load-bearing and enclosing stone structures of buildings, foundations, walls, pillars, lintels, arches, etc., as well as in the construction of transport, hydraulic engineering, and agricultural construction. Stonework is a complex of basic and auxiliary processes. The main ones include laying bricks and other artificial or natural stones on a mortar, while the auxiliary ones include installation of scaffolding, preparation of materials, laying of rebar, etc. A stone structure is constructed from individual stones laid in a certain order and held together. Homonolocheny solution. Despite the measures taken and every effort to use industrial methods of construction of buildings and structures, the volume of stonework in modern civil, agricultural, and industrial construction remains significant. Every year, 50 billion bricks are produced for construction in the country, which is approximately 125 million meters cubed of masonry. Local raw materials are used for the production of bricks. Brick is quite strong, durable, fire-resistant, has high thermal properties. It can be used to build buildings of various architectural expressiveness. However, the process of masonry from small piece stones does not lend itself to mechanization and therefore is traditionally performed manually, which causes a high labor intensity of work. High material consumption and a significant mass of stone structures require high transport costs. In winter conditions, masonry on the solution is complicated due to the implementation of additional special technological and organizational measures. The domestic practice of construction of bricks is somewhat behind Aufsarubasnoi. Thus, the brand of bricks produced in capitalist countries is 125 to 600, and the bulk of the bricks are produced with the brand 400. The production of hollow bricks is 80% of the total mass. Domestic bricks and GOST have the highest grade of 200, hollow bricks are used for about 14%. Foreign firms pay great attention to the quality of bricks, appearance, shape, color, produce shaped bricks for decorative masonry. The height of brick buildings in Switzerland has been increased to 30 stories due to the use of effective thermal insulation materials in the upper floors. Currently, promising areas in the development of stone works are the improvement of stone structures, their facilitation while maintaining the necessary load-bearing capacity and thermal insulation properties, which is achieved by using high-strength bricks, masonry reinforcement, the use of hollow ceramic materials and stones made of cellular concrete, the introduction of lightweight masonry with effective plate heat insulating materials. There is a search for better forms of organization and methods of work in order to achieve greater productivity of teams with high quality of work. One of the most difficult tasks is the development and implementation of effective methods of winter masonry, which is of particular importance in connection with the unfolding construction in Siberia and the far north of the country. Much attention is paid to the issues of labor protection, in particular, ensuring safety and improving working conditions. An attempt to industrialize the process of stone work is the use of vibrobrick panels and blocks produced in the construction industry. Types of masonry and materials for stone work. Depending on the material used, there are masonry made of artificial stone, solid brick and lightweight, small block of ceramic and concrete stones, masonry made of natural stones, rubble and plank. In the CIS, various ceramic wall materials are produced. Ordinary brick, 250x 120x 65 mm, thickened 88 mm thick, and modular, with a ZM module equals 30 cm, size 288x 138x 63 mm, ceramic stones are ordinary. 250x 120x 28 mm, enlarged, 250 mm wide, modular, 288x 138x 138 mm, as well as stones with horizontal voids, 250x 120 mm. A stone weighing no more than 4 kilograms is sometimes called one-handed, and weighing up to 13-16 kg, two-handed, depending on whether it can be laid with one or two hands by a mason. Solid brickwork is widely used in construction practice. Such masonry is used in the construction of load-bearing and enclosing structures of buildings. Lightweight brickwork includes a layer of effective thermal insulation material filled in or in the form of blocks and slabs. Only two parallel walls are laid out of bricks designed to accommodate the design loads, usually half a brick each. Lightweight masonry is used primarily for the construction of self-supporting walls of industrial single-story and multi-story buildings, as well as for the walls of the upper floors of residential buildings. Small block masonry made of hollow ceramic stones has high thermal properties and is mainly used in the external walls of heated buildings. The walls of frame buildings are made of small solid or hollow concrete stones. Stones made of hygroscopic materials should not be used in areas with high humidity. The external walls laid out of them are plastered. Rubble masonry is made of ragged stone of irregular shape rubble. The front surfaces of structures are laid out of bed stones or lined with bricks. Rubble masonry has a large mass, so it is used for the construction of underground structures and plinths of buildings, retaining walls. Hydraulic, transport and other engineering structures and agricultural production buildings. Rubble masonry is made in the formwork by embedding stones in a layer of concrete. Such masonry is stronger than rubble and more economical than concrete. Plank masonry is made of natural stones and blocks of regular shape. In addition to hard rocks, soft porous rocks with a density of 900-2200 kg/m3 are used for making stones and blocks. Plank masonry is used in residential construction, as well as in the construction of monumental structures. Masonry made of natural stones is strong, durable, decorative, does not require additional processing of facades, and is cheap to use. It is widespread in mountainous areas. Masonry mortars used for the construction of stone structures must meet the requirements of standards and technical conditions in terms of their physical and chemical properties: strength, frost resistance, mobility, and water retention capacity. The composition, grade and main characteristics of the solution are set by the project depending on the purpose and working conditions of the structure, as well as on the conditions of work. The grade of the solution is determined by the compressive strength, about 4, 10, 25, 50, 75, 100, 150 and 200. Mark 0 was introduced for structures with thawed solution. According to the type of binder, solutions are divided into cement, lime, clay and complex. Solutions on Portland cement and Portland cement are used for all types of masonry, performed in summer and winter conditions. The use of lime solutions and local binders is allowed in the construction of low-rise buildings, as well as for masonry partitions. Such solutions cannot be used for winter laying. Solutions based on pozzolanic and sulfate-resistant Portland cement are intended for stone structures exposed to aggressive and waste water. The use of clay solutions is limited to masonry stoves and chimneys, as well as brickwork and refractory masonry. Masonry reinforcement is calculated in load-bearing structures in order to increase their strength, solidity, earthquake resistance, as well as structurally, for example, in strabs, abutments and corners of walls. Reinforcement is made transversely, in which nets are laid in horizontal mortar seams, and longitudinally, when the reinforcement is placed in furrows or channels left in the masonry. Reinforced stone structures are made of all types of bricks of grades not lower than 75, on solutions of grades 50 and higher. As fittings, hot-rolled steel of classes AI and A2 is used, and ordinary cold-drawn reinforcing wire BI. For embedded parts in masonry, use strip, sheet or shaped steel. The first rule of cutting is that the stones should be laid in flat layers, rows perpendicular. Figure 1. Rules for cutting masonry: A scheme for transmitting the vertical load on the lower stone. B action on the stones of the inclined force. P. C correct division of the masonry layer, with mutually perpendicular planes. D incorrect division of the masonry layer. D masonry without ligation of seams. D masonry with overlap to the direction of the current load. This rule follows from the properties of the stone to resist compression well, and work poorly on stretching and bending. In this regard, it is necessary to place stones in the masonry array so that they are compressed. In order to avoid bending or stretching, the support of the overlying stone on the lower one should not occur at individual points, but along the entire bed, i.e. along the plane Fig. 1a. For this reason, the masonry array is divided into flat layers, rows. The layers should be positioned so that the force acting on the masonry is directed perpendicular to them. Otherwise, there is a shift in the masonry at the weakest point, the mortar seam between the layers, Fig. 1b. The deviation of the force direction from the vertical angle A is allowed no more than 17 degrees. Within these limits, the shear force is extinguished by the friction forces between the layers of stones. In most cases, the masonry forces are transmitted vertically in pillars, walls, foundations, so it is performed in horizontal layers. In arches and vaults, there are forces acting in each section tangent to the pressure curve. Because of this, their masonry is divided into planes radially. The second rule of cutting requires dividing the masonry with 3 mutually perpendicular planes. In this case, the stones take the form of a rectangular parallelepiped, Fig. 1b. In the masonry array with this division, seams appear, horizontal, along the bed of the layer and vertical, transverse and longitudinal. If the division of the masonry is made with inclined, mutually non-perpendicular planes, then wedge-shaped stones will appear in it under load. They will tend to push apart neighboring stones, as well as stones with easily chipped sharp corners. The third rule of cutting prescribes compliance with the ligation of seams to ensure the solidity of the masonry. If the masonry Array, made without ligation of seams, Rashlanite 3 through planes, then the masonry will consist of separate, not connected to each other columns with a cross-section of one stone, Fig. 1d. In order to make the stones work together under load, it is necessary to move the overlying stones relative to the lower ones, i.e. to cover the vertical seams of the lower layer with the stones of the upper layer. This technique is called ligation of seams in adjacent rows of masonry, Fig. 1e. Naturally, these rules are fully observed only in masonry made of artificial or natural stones of the correct shape. In rubble masonry, the shape of the ragged stone is arbitrary, so it is extremely difficult to observe the division of the masonry array into flat layers. 4. Rice 2 shows the main wall thickness in multiples of half a brick. Vertical, longitudinal and transverse seams have a thickness of 8 to 15 millimeters. On average, the thickness of vertical seams should be 10 millimeters, which is dictated by the condition of dressing the seams, Fig. 2b. The solution in horizontal seams of a laying, except binding, o monolic of Annie, of brick rows, serves for alignment of a bed, uniform transfer of loading from a layer to a layer. At the same time, the device of thickened seams reduces the strength of masonry, and leads to higher costs, and increased labor intensity of work on the site. The optimal thickness of the horizontal seam should be at least 10 millimeters, but not more than 15 millimeters. Within one floor, the average thickness of horizontal seams should be 12 millimeters depending on the purpose of the structure. External mortar seams are made convex, concave or flush. The outer and inner parts of the wall formed from tikhoff or spoon rows are called versts, and the inner filling of the wall between versts is called zabutka.